So you know what the derivative of sine is. What's the derivative of sine? What's the derivative of cosine? Negative sine. Just like sine and cosine are functions and have derivatives, their inverses have derivatives as well. So you know on the calculator, you go second sine, you get that sine inverse. That is an operation itself. And so if you see the derivative of arc sine, that's the same thing as the derivative of sine inverse of x. Note that that is not 1 over sine of x. 1 over sine is cosecant. But the derivative of arc sine is 1 over the square root of 1 minus x squared. Now, what's nice is that if you can memorize that, you then know arc cosine. Arc cosine, or cosine inverse, the derivative is negative 1 over the square root of 1 minus x squared. So it's the same thing, it's just negative. Yep. And then arc tangent, the derivative will be 1 over 1 plus x squared. If you know arctan, you know arctan. It's negative 1 over 1 plus x squared. You're seeing a little bit of a pattern develop. The derivatives are basically they're just opposites, so that's kind of the pattern. Derivative of arc secant, 1 over x times the square root of x squared minus 1. And then the derivative of arc cosecant would be the negative. Negative 1 over x times square root of x squared minus 1. No, you do not get matching on the final. Yes, you have to memorize them for the final. No, you do not get a sheet of notes. You need to memorize this. Okay? No, so arc sine is the same thing as sine inverse. Just like arc cosine is the same thing as cosine inverse. So these are the derivatives. And I would say that these are the three that you really want to focus on. If you can memorize those three, then you know the other three. So you really don't have to memorize 6, you just have to memorize 3. Yes. No, and I'll hand out the study guide for you today. But this is going to be some key content that you're going to need to know for the final. But just like I expect you to be able to take the derivative, so for your final exam, you're going to have to know how to find the derivative of e to the 3x. Just 3e to the 3x. But you should also know how to find the derivative of x squared plus 2 to the 10th power by using the chain rule. So it's going to be limited to derivatives and limits. Okay? So we got 2 ideas. Furthermore, you get your last assignment tomorrow. On Friday, we're doing a review activity in class, which you will love, I promise. Everybody loves it every year we do it. And then next week, you have 3 days of review in class with no assignments, just time to work on your study guide. Okay? So, what? Yep. Okay, let's try some problems. Number 1, if you don't like to write it like this, you can write it as f of x equals cosine inverse of e to the x. Those mean the same thing. What rule do you think I used to find the derivative? Chain rule. The outside is cosine inverse of u. What's the inside? What's the derivative of e to the x? And what is the derivative of cosine inverse of u? Some people are developing bad habits, and the bad habit is instead of putting a u here, they put an x here. I highly encourage you to make sure you're putting u. 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 If you multiply these together, you get a negative e to the x on top, and on the bottom you get the square root of 1 minus, what do I get if I square e to the x? E to the 2x. That's my derivative. Chain rule. arctan of u, 4 minus 2x, derivative 4 minus 2x, negative 2, derivative arctan, 1 over 1 plus u squared. Multiply them, negative 2 over 1 plus that thing, 4 minus 2x squared. You don't have to multiply it out and combine it together. You can just leave it like that. Yep. We just have these 4 more problems, and you have your worksheet. Sine inverse. Or arc sine of u and the square root of x. What's the derivative of square root of x? 1 over 2 roots of x. Derivative of arc sine. So when I plug the square root of x into there, I will get just x, and then a 2 roots of x will join in the denominator as well, but I just have a 1 on top, bottom 2 roots of x times the root of 1 minus x. Yep. Okay, now let's get a little bit more difficult. What about number 4? What rule? Product. Very good. So I take the derivative of x, which is 1, times the natural log of arc cotangent of x. Plus x times the derivative of natural log of arc cotan. Chain rule. Natural log of u. What's the derivative of arc cotan? Good, Wally. What's the derivative of natural log of u? 1 over u. 1 over u. So this goes here. So I have 1 over arc cotangent of x times that negative 1 over 1 plus x squared. So if I multiply those together, I get a negative 1 in the numerator, right? And that's going to go into this space right here. So instead of a plus x, it's going to be a minus x over 1 plus x squared times arc cotangent of x. So when we did the product rule, we had the derivative of x was 1. So that's why there's no x here. But the second time through, we had to leave the x alone. Yep. That's the answer. It's not very pretty, but these derivatives aren't pretty. Just are what they are. For number 5, it simplifies a little bit better. We get a kind of a nicer looking answer. See, we have the derivative of arc cosecant. And this is going to require the use of the chain rule. You can see that that's mostly what I'm looking for, is that you can set up basic chain rule examples with these type of problems. We had one where you use a product rule, but we're not going to try to get too crazy. So I have cosecant inverse of u, and I have e to the 3x plus 1. So what's the derivative of e to the 3x plus 1? How did you do that? Yeah, you're using the chain rule, but since the derivative of e to the x is just e to the x, it's very easy to take this derivative. You've learned that when you take the derivative of e to something, you just take the derivative of the exponent and place it out front. It goes rather quickly, so that's why I can ask those type of questions, and they generally go pretty quick for you. So, all right, and then cosecant inverse of u, I get -1 over u. Very good. So as I multiply these together, what do I have in the numerator? And then in the denominator, notice that the e to the 3x plus 1, it has to go into two different places. Wherever I have a u, that's where the e to the 3x plus 1 goes. If I take e to the 3x plus 1 and I square it, what do I get? What's the new exponent? 6x plus 2. So e to the 6x plus 2 minus 1. Now what's nice about this problem is it does simplify a little bit. What simplifies? Yeah, e to the 3x plus 1 and e to the 3x plus 1 will divide off. And I get -3 over the root of e to the 6x plus 2 minus 1. These, right. So if you were to take e to the 3x plus 1 and you were to square it, if I have a power to a power, I multiply. Everybody okay? Okay, let's do the last one. Then you can start working. You'll get some brain food, and life will be good. Nice short Wednesday. Should give a shout out to Dylan. D. Weiland enjoying the beach. We hope he's enjoying it, huh? What? Why not? All right, here we go. Last one. What rule? So arctan of u, or tangent inverse of u, and u is x minus the square root of 1 plus x squared. Derivative of arctan. So that piece is going to go into the u squared. That's interesting. No. Derivative of x minus the root of 1 plus x squared. What's it? 1 minus that derivative. How do I do that derivative? Chain rule. Good. Root of u. Where would we be without the chain rule? I mean, right? It's just... No. I did. You... Yeah. To the YouTube audience, I was just asked if I came up with the name of chain rule, which I appreciate. No, I appreciate that. I appreciate that. Chain rule is a very famous derivative, and it actually has to do with. I'll show you the relationship with the chain idea here later on. So, but so we got the derivative. We got 1 over 2 roots of u, and we've got 2x. So I'm going to multiply those together, and what happens? 2's cancel, so I get x over the root of 1 plus x squared. And so I'm going to have this beast right here times that beast right there. So I get 1 over 1 plus the quantity x minus the root of 1 plus x squared squared. So I plugged this in for you. That is going to be times 1 minus x over the square root of 1 plus x squared. It ain't pretty, but it doesn't have to be. It's just what it is, yeah. Doesn't really simplify. Got it? I'll hand out the homework.